Children, in this video we are going to learn about LACO. LACO means linear combination of atomic orbitals. So according to linear combination of atomic orbitals, when two atoms, LCAO, linear combination of atomic orbitals. So according to linear combination of atomic orbitals, when two atoms come close to one another, two atomic orbitals having comparable energy, same symmetry and possessing large overlaps combine to form two molecular orbitals. Already I taught in the postulates of molecular orbital theory. The molecular orbital with higher energy gives to a repulsive state and it is called antibonding molecular orbital, that is psi A. While molecular orbital with a lower energy gives rise to attractive state called as bonding molecular orbitals, that is psi B. Two atomic orbitals. This is the atomic orbital combine to form two molecular orbitals having lower energy, that is psi B, having higher energy, that is psi A. The lower energy, that is called as bonding molecular orbital, higher energy, that is called as anti-bonding molecular orbital. Now, as electrons have dual nature of particle and wave, they can be considered as moving in the atom in the form of a wave. See, like this is the nucleus of an atom. This is an atom. If an electron want to move, it move like this. That is, electron will move like this. Once more it will move like this. That is having crust and trough, like a wave. Crust and trough. So electron will not move in a straight line. It will move like this. Surrounds an atom. So this is represented as the wave function represented as psi. Let us consider psi A, that is psi A is the wave function of electron of atom A and psi B is the wave function of an electron of atom B. Therefore, wave function of bonding molecular orbital, that is psi bonding, is equal to psi A plus psi B. The wave function of antibonding molecular orbital is psi antibonding is equal to psi A minus psi B. For bonding plus sign, for antibonding minus sign. Now, a wave already I taught a wave has a crust and a trough. So, when the wave has a crust and trough, when crust of one wave combines with the crust of the another wave. Crust, trough, crust, trough, crust. This is one wave that is called, considered as psi B. Consider a second wave. psi A. Crest of one wave combined with the crest of the other wave, then the amplitude of the resultant wave increases. That is called psi bonding. This is given as psi bonding equal to psi A plus psi B. That is, the resultant wave gives higher amplitude. See, that is the imaginary horizontal line. Electron wave above the horizontal line gives a positive sign, while that of below is negative. Above it is positive, below it is negative in a wave. So in this case, both the electron wave are on the same side. That is, the sign of the two wave function are same, such that wave function are regarded as they are in the same phase. So when they combine, they give a large resultant wave. See, positive, positive, giving a large resultant wave or molecular orbital. Such a molecular orbital are called as bonding molecular orbitals. So when two atoms combine, they give the bonding molecular orbitals. This part shows high electron density at the center, then at the corners low electron density. Low electron density at the corners, high electron density at the center. This is for the positive wave. This is for the bonding. Now, when two waves are in opposite direction, that is, crest of one wave combines with the trough of the other wave, like this. Crest of one wave combines with the trough of the another wave, the amplitude get cancelled. See, the amplitude get cancelled. As the waves are in out of phase, the positive part of one wave combines with the negative part of the other wave. The resultant wave, they get cancel each other. So positive combines with the negative, resultant wave get cancelled. In this case, the probability of finding electron is negligible, called antibonding. So one atom, other atom forming here high electron density at the corner and low electron density at the center. High electron density at the corners, low electron density in the center. So in the bonding molecular orbital, electron density between the two nuclei is get increased. The nuclei are shielded from each other, and there is greater attractive forces of the nuclei for the electron. This results in lowering of delta E, that is called bonding energy, exchange energy. Now, in the antibonding molecular orbital, the electron density between the two nuclei get decreased. The nuclei are partially exposed to each other, and there is greater nuclear repulsion. This results in increase of energy. So the bonding orbital has a lower energy level than the isolated atoms by a quantity called delta E. Because of the delta E, bonding orbital is more stable. On the other hand, antibonding orbital is at a higher energy level than the isolated atom and is then destabilized by delta E. The quantity delta E is called as exchange energy. This is clearly given in your book, page number 98. You can go through bonding and antibonding. what is the principles laid on LACO, then for the bonding, or how the crust and trough followed, for the anti-bonding, how the crust and trough followed, everything clearly given in the book.